Here we have d2y by dx squared plus 3dy by dx plus 2y equal to cos x plus sin x. How are we going to solve this? First thing we need to do is we have d2y by dx squared, we can call the y double prime. So we're going to solve the auxiliary equation first. So we have y double prime. All right, what I'm going to do is just solve the auxiliary equation. We know the auxiliary for this would be u squared plus 3u plus 2 equals 0. So I know I'm skipping a few steps, but u squared plus 3u plus 2 equals 0. This would be the auxiliary equation. Solving the auxiliary equation, we're then going to factorize this. Factorize, we know what we get is u this look like u and u. This would be 2 and 1. Signs are the same and both of them positive. So plus and plus. Yeah, man. Nice. So then now, once you get to that stage now, we know that u would be equal to -1 or u would be equal to -2. So since these are what we're getting for u, then that means our complementary function, I like to call it YC. Complementary function is going to be a times e to the minus x, a times e to the minus x, plus b times e to the minus 2x. Yeah, man. Nice. So this is our complementary function. Now that we have our complementary function, and this is what we have, we're good. Next thing we need to do is find our particular integral. To find our particular integral, all right, so we're going to find our particular integral. So writing this down, we know that we're solving y double prime plus 3y prime plus 2y, and that's equal to, that's cos x plus sin x. It's cos x plus sin x. So since this is what we have to be solving, what are we going to do? Well, what we're going to do now is we're going to call our particular integral yp, and our particular integral is going to take the form of this cos x plus sin x, but it's going to take the form of, I don't want to use a since a is around there already, so it's going to take the form of p cos x plus q sin x. That's the form it's going to take, p cos x plus q sin x. Yes. So now we know that yp prime is then going to be equal to the derivative of this. The derivative of this is going to be, when I differentiate cos, I get minus sine. So it's going to be minus p sine x, that's minus p sine x plus q cos x. That's what I get. Yeah, man. Then I need to find the second derivative now. The second derivative is just yp prime prime, and yp prime prime will be, when I differentiate sine, I get cos, so this will become minus p cos x. Then when I differentiate cos, I get minus sine, so this will become minus q sine x. Yeah, man. Gucci, and we're nice. Now that we get this, all of this, we're going to put them together. We're going to put them together in this right here. And so putting them in this equation, what we're going to get is y double prime is minus p cos x minus q sine x. It is going to be plus 3 times y prime where y prime is minus p sine x plus q cos x. And then we have plus 2y plus 2 times y, where y is p cos x plus q sine x. Yeah, man. So this is what we have. And this is equal to, remember, it's equal to cos x plus sine x. All we're going to do is simplify both sides and solve for p and q. So solving for p and q now, let's expand the right-hand side, or the left-hand side rather. The left-hand side will become minus p cos x minus q sine x. Then that looks like minus 3p sine x plus 3, look like 3q cos x plus 2p cos x, and that's plus 2q sine x, and that's equal to cos x plus sine x. That's what we're getting. Nice and easy, soft. Now that this is what we're getting now, what do? What we do is we equate the cos part. This is a minus p cos x, and this is the 3q cos x, and this is the 2p cos x. We equate that part, and so let's equate that, and equating the cos part to just cos x, that will allow us to get one equation. So equating cos x, what we're getting is, let's equate the cos x then in black. What we're getting is minus p cos x plus 3q cos x, and that is now plus 2p cos x, and that is equal to cos x. Now what I'm going to do is divide through by cos x. If I divide through by cos x, I will get minus p plus 3q, and then that looks like plus 2p equal to 1. And so that simplify out to be, if I add these p, minus p and 2p is just p, so that's p plus 3q, p plus 3q equal 1. Good. Now over here, I'm going to be equating my, sine x then. So let's equate sine x over here. Equating sine x. So equating my sine x, what I'm going to get is minus q sine x, that's minus 3p sine x, and that is now plus 2 sine x, that equals sine x. So now I'm going to divide through by sine x to get minus q minus 3p, and that looks like plus 2q, that equal 1. So when I simplify that, what I'm getting is 2q minus q is q minus 3p, q minus 3p equal 1. Yeah, man. Nice. So that is what we have. We have this and we have this. Now, what I would do is from this side, I'm going to make q the subject. So q is equal to 1 plus 3p. And so I'm going to substitute q equal 1 plus 3p in here, plug it in there. Then what I'm going to get is, this becomes p plus 3 times q, which is 1 plus 3p. This is equal to 1. Going down, I get p plus 3 plus 9p is equal to 1. So what I'm getting is 10p is equal to, carry over the 3 over here, which is negative 2. So what I'm getting is p is equal to minus 1 over 5. That is p. Since this is what I get for p, then I can now evaluate q. q is then going to be equal to 1 plus 3 times minus 1 over 5. And so what we end up getting is q is equal to 1 plus 3 times minus 1 over 5 is 2 over 5. That is q. Nice. So now that we get p and q, then that means our particular integral, we can write our yp now. So our particular integral yp is equal to p cos x. So it is minus 1 over 5 cos x minus 1 over 5 cos x plus 2 over 5 sine x. That is our particular integral. Nice and easy and soft. Once you do this now, we're good, because now we're able now to, of course, now we're able to put our solution together. So now we can write our general solution. Our general solution, remember, it's going to be equal to the complementary function plus our particular integral. And so the general solution is working out to be y is equal to a e to the minus x, a e to the minus x, plus this is now b e to the minus 2x, that is our complementary function, plus our particular integral, which was minus 1 over 5 times cos x plus 2 over 5 sine x, minus 1 over 5 cos x plus 2 over 5 sine x. That's the complementary function. Nice and easy and soft. Yeah, man, soft. Soft.